Good morning, everyone. In the last session, we are trying to discuss about the one of the important example on this particular linked list. We identified some of the information. So now observe carefully what we did basically here. We call the add method, add first method, add last method, offer method, something like set method, add all method, and get method. So these are all the method we identified in the last session. Okay, so these are all the important examples we discuss how this particular linked list is working internally. Now, what we will do, we'll try to discuss about the another important information, how this particular linked list is going to work internally. Okay, so now if we observe carefully, any the method pending from the collection interface, so something like a remove method. Okay, we'll understand here how this remove method will work internally. So for example, if I'm going to call remove method. Now you can see this remove method is not taking any parameter. Okay, so this remove method is not taking any parameters internally. What we need to understand, how this remove method is going to work internally, we need to understand very carefully. Okay, so now what I'm doing it, I'm trying to run this example in the debug mode so that we'll understand how this remove method is going to work internally. Okay, so now I'm calling the set method, add all method. So finally, we're calling this remove method. Okay, finally, we're calling this remove method. Now observe carefully. So what is the method we're calling? Remove first method we're calling. Okay, whenever we are calling the remove method internally, it is calling the remove first method. So far, how many nodes we are having? Here now you can see first and second, third, fourth, fifth, sixth, seven, eight, nine. Okay, around 9 methods are available. Like 9 objects are we inserted into inside this particular linked list. So whenever we are inserting like this, so which method will call? This is the node first here. This first method, like first node, it's going to remove from this particular linked list. So what is the first here? EF. Okay, EF is our first node. The first node we already discussed here. Previous node it will contain the null values. Okay, and the last node next value will contain null. This is important. If this particular f is null, we are trying to throw in a exception. No such element exception. Otherwise, unlink first here. Now what we are doing is we are trying to remove the linking operation. Okay, this is important. Just we are trying to remove the linking operation. Now you can see I'm calling the unlink first. So what I'm passing here, if I'm trying to pass. Whenever I'm trying to pass this particular f, first what I'm doing is I'm trying to load the f dot item. So what is the value we are going to load? We'll try to load about the ef. Okay, now you can see ef. Okay, this is the item we are loading. After this, I'm trying to load f dot next here. So whatever the next node we are having the relation. For example, how we are having the relations here. This is the internal relation about the linked list. So this particular next will contain this particular another node here. Okay, so I'm loading whenever I'm trying to call the next here. This section will load. Inside this section, it is having the objective references. So this objective, getting the point, this particular node is trying to load here. This particular node will contain the previous and next. Okay, if it is contained, now you can see I'm trying to load the next node. Now you can see the next if I'm going to make, it is containing next and previous. Getting the point, it is containing next and previous along with the value. The item, whatever the item we are having, all the values we are having. Getting the point. Now what I'm doing is after this I'm trying to make f dot next f dot item. Getting the point. What I'm doing is whatever this particular f dot next. So this particular I'm making as a null. Okay, this item also I'm making null. Now what you can understand here, previously, because this is the first record, initially only we made as a null, but right now these two records we are making null. Okay, right now these two records we are making null. Whenever we are making null, now what we need to understand here? What we need to understand? This particular node is not going to have any relation here. Getting the point? This particular node we don't have any relation. So now observe carefully what we need to understand here. Here I'm trying to call item next. Getting the point? F dot item is null and f dot next is also null. And whatever this particular next we made, getting the point? Whatever this particular next we load, so this particular next I'm trying to initializing as a first here. Okay, I'm trying to initializing as a first. For example, whenever I'm trying to initializing this, but it is containing previous signed to next. But as a first record, we cannot have this particular previous references, right? For the first records, the previous become null here. Okay, but here we are having the option, like we are having the references object. So we'll see how this reference is going to remove here. Okay, now observe carefully. This is the next we are having, and what we are doing here, if the next is null, we are making the last, but this is not the next is not a null. And now if you see here, now what I'm doing here, next dot previous null. Now what you understand here, so for this purpose also we are making null. Getting the point? So far we made this particular node as a null, but whatever the next node we provided, the next node, what I'm doing it, the previous value I'm making as a null. Okay, right now this is the y and z, the next references will contain here. Okay, the next references will contain like this. Now what you understand here, this particular node we deleted the whatever the data is having inside this particular node. Inside this particular node we remove the data, so there is no relation. There is no relation between the another nodes here. So because whatever the relations we are having, we remove the all the relations. Something like we made the null here. Okay, we made null values here. So once we made this particular node is empty. Okay, this particular node is empty, and this particular node we made as a first node. How we are making the first node? First we are calling line number 191 as a the next node. I'm trying to initializing into the first, and if it is next is null, we are making as a last because it is not a null. So because of this, now what I'm doing is I'm trying to make this particular 185. Whatever this particular next dot previous we are having, the next dot previous we are making as a null here. Okay, next dot previous we are making as a null. So whenever we are making null, now what I'm doing is we are decreasing the size, the mod count will increase automatically, and we are retaining this particular element here because it is a remove method. So what is the element we remove? The particular element we are retaining. So what is the element we are removing here? EF. Can you understand? This particular element we are removing here. This is one of the very important example. Okay, we need to understand here how this particular remove method is working internally. So remove method basically it is trying to remove the operation, like its relations here, not operations. So it's, we can understand here it is trying to remove the operations here. Okay, this is one of the important example we need to understand here. Getting the point? This is one of the important example we need to understand regarding this particular remove. Now, if I'm going to print this remove method, so which value it will print here? The value it will print as a EF here. The value it will print as a EF. Now you can see the first one is printing EF, and we are calling internally get. Okay, we are calling this particular ll dot get linked list dot get to. This is right now is printing CD. Getting the point? It right now it is printing CD. Now finally these are all the values we are having. Okay, these are all the values we are having here. This is one of the important example we are discussing regarding this particular remove method, which is not taking any parameter. Okay, now I'm trying to comment out this. So again, now again I'm going to call ll dot remove method. Now you can see, so how many the remove method we are having? Two more remove method we are having. Getting the point? So two more remove method we are having here. Now this remove method, this particular remove method, I'm trying to make as a index here. The index basically, so I will give as a 2, or we can move on to the 3. Okay. So whenever I'm trying to call this particular index, it is trying to returning as a string. Getting the point? Now you can see this remove method is expecting int index here. Now finally, what I'm doing here, this particular method is trying to returning string. Now what you can understand here, this remove method also will return whatever the object is removed. Getting the point? Or whatever the item is removed. Getting the point? This is very important here. Now let me run this example one more time in the debug mode. So basically here, what we are doing is we are trying to providing the index. So this we already identified here. Whenever we are trying to providing this particular index here, it will try to load the specified node here. Based on this particular index, it will try to load the specified node. The node is going to remove the, getting the point, it's going to remove the relationships here, like whatever the next node, previous node we are going to have, so those nodes are going to remove here. Now you can see offer set add all, I'm calling the remove method. Now whenever I'm calling this particular remove method, now whenever we are providing this particular index here, again we are checking this particular check element index here. Now so the particular check element is index is returning false here. Okay, now finally, what I'm doing is unlink. Unlink I'm calling, but before unlink, what we need to understand internally, we are calling node here. Getting the point? We are calling node. Whenever we are calling node, how it is going to load? Here, what is the value we are providing this particular index? We are passing as a 3. So whenever I'm trying to pass as a 3, now you can see this is the conditions we are having, and if this particular condition is not satisfied, it will move on to the else section. It will repeat the loop. Okay. Once it is repeats the loop, now we are trying to returning the load. Getting the point? So this is first to last, this loop will repeat, and this particular loop will repeat last to first. Okay, it's like a reverse order. So based on this particular order, now what happens internally? So whatever the node is going to satisfy based on this particular condition, the node is going to return here. Okay, the particular node is going to return. So once this particular node is returned, now again same, whatever we did in the earlier method, it will try to call the unlink method, and based on this particular unlink, here we are trying to passing here. So observe, item we are loading, next we are loading, and previous we are loading. So based on this particular node, we are trying to load all the values here. Okay, so once we node, if the previous is null, we are making as a first. If the else section, now what I'm doing is previous dot next, getting the point, next dot previous. We are making the null values because finally, whatever the index we are having, the node we need to make as a empty. Finally, we need to make as a empty. Okay, so now observe, I'm going to call this particular node is calling. So index we given as a 3. Now you can see if condition is satisfied here. Getting the point? If condition basically it is satisfied because of this particular if condition, like index less than size here. After this, now what you need to understand first. So I'm trying to load the first node. And what is the first node we are having? Here we'll see inside this EF. Okay, EF is the first node. How we can identify? Previous is null. Okay, for the first node, previous node is it will be null here. Okay, now what is the loop we are doing here? I is equals to 0, I less than index. I index we given as a 3, I value it is starting with 0. Okay, this particular loop will repeat 3 times here. Now you can see what happening internally, x is equals to x dot next. Okay, what is the x now? What is the x now? Now we need to understand yz. The EF is now replaced with yz. Now whenever I'm trying to call one more time, now this time set. This time the another node we are getting set, and this is the final iteration. So what is the final iteration we are getting? CD. Okay, the final iteration this is CD. Now Whenever the value is increased here, now it is coming out of this. So what is the node we are returning? The node we are returning CD related node. Now you can see it is containing previous and next. So two values it is containing here. Okay. Now we have a clarity which node we are trying to removing here. The CD related node, whatever we are having, the node we are trying to remove here. Okay. This is important we need to understand. So we identify based on this particular index. Okay, based on this particular index, we are trying to loading this particular node. So once we load this particular node, we are returning, and again I'm calling unlink method. Okay, so item and previous node and next node. Now you can see this is an item CD, and this is the next, and this is the previous one. So finally, previous is null? No. The previous is contain some information. So previous is not a null. So it is moving on to this particular section. And whatever the previous node we provided here, the previous node, what I'm doing it, whatever we are having previous dot next, this particular next we are making. So if you see, observe, so I'm going to make diagram so that we can easily understand it. Okay. And here we are having CD value, the previous value. So first we'll see what is the previous value we are having. This is the previous node. So what is the previous node we are having here? Something like a YZ. Here I'm making YZ node. Okay. And what about this particular next node? Next node it is a 1, 2. So here I'm going to make 1, 2. Now observe carefully what we need to understand here. Here, what we need to understand here? This is important section we need to understand here. Previous dot next. Okay. Previous dot next. So what I'm getting here? Basically, what is the previous dot next here? CD. Okay. Previous dot next. What is the previous value basically? Here, YZ. Getting the point? So this is only the previous node. But whenever I'm trying to call this particular node, I'm getting the current value. Okay. This particular CD it is returning. So whenever it is returning, now what I'm doing is this node I'm making. Okay, this node. Now if you see YZ is a different node we are having. Okay, YZ is a different node. Now whenever I'm calling this next, this particular next, now it is pointed to this particular CD value. And here 12 is a different node. Okay, 12 is this is the 12 node. So again this will contain the previous and next. This will contain the previous and next. Now observe carefully what you need to understand. So YZ is a one node, CD is another node, and 12. So CD it's containing this is the previous node, and CD it is containing this is the next node. Okay. Now if you observe carefully, whenever I'm calling this particular previous node called YZ, whenever I'm calling the previous dot next, it should return this. Okay, this node is going to return basically, but right now we are trying to remove the object from this particular node. Now what I'm trying to do, this particular node, now it is pointing to this particular node. Okay, this particular node. If we observe carefully, this next, what is the next we are getting here? What is the next I'm getting here? Now you can read this. It is a 12 one. Okay. Now where I'm trying to initializing? Previous. Previous is basically how I'm noding from the current node. What is the node? This CD. Okay. This particular element also we can identify CD. Okay. So this is the CD related section. The CD will contain the next and the previous. So previous basically YZ. So previous dot next. Something like YZ dot next. YZ dot next basically it is a CD. Now I'm trying to replace with this particular 12. Okay, now what you understand here? Here, the next node, whatever the next node we are having, now the next node is now replaced here. And finally, what I'm doing is x dot previous, x dot previous. So here this is the next. Okay, this is the x here. So I'm making null. I'm making null. Now this no longer available. Okay, x is right now, this is the only the x here. So x dot element x dot item we call here, that is returning CD. Now this value we are making null. Getting the point? The previous information removed. The previous information is removed, but still we have a next information. Getting the point? We have a next information. Now if you see, if I'm going to open this, now you can see previous is not available right now, only next is available, the item we are having CD. Getting the point? This is very important here, how this particular, the delete node is working internally. Basically, delete node internally, just it's going to remove the references, whatever the relations we had with the previous node and next node. So this is very, very important to the delete node information. Okay, now we understand here. After this else section is completed. Now what you understand here, previous dot next. The YZ now it is pointing to this particular 12, and the second line here, x dot previous null. This previous we made as a null. Okay, and next, whatever this particular next is also not null. Now whenever it is not a null, now what we need to understand, next dot previous. Okay, next dot previous. Basically, what is the next dot previous? Okay, what is the next here? Something like a 12. Next dot previous. Next dot previous, basically it is a CD relation. Now you can see CD we are having. Next dot previous. So this is the previous link. If I'm trying to opening this internally, I'm getting as a CD relation. Okay, now next dot previous, I'm making the previous. Next dot previous, I'm making the previous. Now observe carefully. So this previous, basically it is pointing to this particular node. Okay, it is pointing to this particular node. Now this node no longer available because of this particular 229. Getting the point? 229 line number. This particular no longer available. Directly, I'm trying to point it to this particular node. Okay, directly I am pointing to this particular node because this is the previous one. This is the previous one we are having. So now if I'm trying to point it to here, now previous node is YZ. Sorry, set. Oh, sorry. X dot previous, maybe we have a now we'll see x dot previous. So now we will get as a null. Okay, now you can see. So it is now replacing with this particular value. Because of this, the previous is modified. And whenever you are seeing this particular x here, whenever you are trying to see this particular x here, now we will understand all the values here. So finally, whatever this particular x we are having, this x is null. The x is only next node is null, previous node is null. Only the item we are having. Getting the point? The item we are having. How we can understand this item here using this particular x dot item? Again, we are making null. X dot item. Now finally, whatever the node we have, this particular x here, all the values are null. All the values are null. Okay, item null, next node is null, and previous node is null. So finally, everything is null here. Okay, and here also, this node also we made just now null. All the values null. So we replace the links, whatever the relations we have, we replace to the previous node and next node. Okay, so any questions regarding this remove method? Very, very important, this remove method. Getting the point? So remove method internally based on the index, based on this particular like the index, or if you are trying to without the index also, first it will load the specified node, and it will try to check about the whether this particular node will contain any previous node or next node. So those nodes are going to remove here. Okay, so any questions here regarding this particular remove method? Anyone having any questions? Okay, now we identify the two remove method. So one more remove method we are having, something like this remove method is expecting object here. This remove method is expecting object here. Now what I will do, I am going to give something like xyz, something like xyz. Now whenever we are trying to make this particular xyz, we'll understand here how this xyz remove method is going to work, because this method is expecting object here. Okay, the specified object basically it is not available inside this particular linked list. Inside this particular linked list. Now observe, for first set add all. Finally, we are calling the same remove method. Now I'm trying to move on to this. So here we are passing object as a parameter. Whenever we are passing this particular object as a parameter, we are checking the condition. So this is not a null. Okay, if condition is fail. Now we are coming back to the else section. Now observe carefully. So this you need to understand very carefully. This is the node. First node I'm loading. Okay, first node I'm trying to set into this particular x here, and this is the conditional block x not equals to null, and x is equals to x dot next. So what you understand here, from first iteration to, it will try to move on to the last iterations here. Okay, it will move on to the last iterations here. So this is very important here. How many nodes we are having? So something 9 nodes we are having. This 9 nodes are going to repeated from this particular line number 368. This is important. This section will call it as a initialization. Okay. This section will call it as a condition. And this is the iteration. Okay. This already we discussed here, but only here instead of providing the int value, we are trying to work on the node related section. We are trying to work on this particular node relation section here. Okay, so it will try to repeat the 9 times. Inside the 9 times, now you can see what we are doing is we are trying to call the one of the equals method. Okay, equals method we are calling. So equals dot x dot item. If it is matched, we are calling unlink method. We are calling whatever the unlink just now we discussed here, the unlink method is calling x. X is basically node. Okay, if any node is not matched here, what happens internally? So this loop will repeat until the condition fail. So it will come out of that. Okay, so this is very important here. So finally, what we will do, we'll try to repeat all the loops here. Observe carefully how I'm trying to repeat. Now you can see one item fail, second item fail, like second node is fail, third node is fail. Okay, and fourth node is fail, fifth, getting the pen, 6 and 7, 8. So this is the final node. Now you can see it will come out of this. So finally, we are trying to removing, like returning false here. Getting the pen. So why the condition is not satisfied? Getting the pen. Here, what we provided, XYZ. And XYZ related node we don't have here. Getting the pen. We don't have the XYZ related node. This is very important information we need to understand here. Getting the point. This is the way the particular object related node it is going to call. Internally it is checking the object value, and if it is not matched here, it is trying to print this particular value. Okay, so this is all about the another remove method we have. Basically we have 3 methods here. So first method, it is trying to not taking any values, and the second remove method, it is expecting index here. Okay, and the third remove method basically is expecting object here. This is important remove method we are having. We identified each and every remove method internally it working. So most of the cases these two are the same. Okay, most of the cases, these two are the same. So here we are providing the index. Based on this, we load the specified node, and we are providing the item. Basically, it will try to check over the item. If the item is matched here, again this node also it's going to load the same. Once item is matched here, it will try to load the node. So again, same here, and finally, one method we are going to call internally unlink. Okay, unlink internally, it is expecting node here, node as a parameter. This is the method it's going to call in the two cases here. Okay, these are all about the remove method we identified here. Now I'm going to call the remove all method. Remove all method is expecting collection here. Is expecting collection. So what is the collection we can pass here? I'm going to pass AL. Because here we need to specify the multiple objects, not a single object. The above three method we discuss about the single objects here. Now I'm trying to discuss about the how we can pass a bulk of object at a time. So that we are going to pass as a using this particular array list, and these are all the four object I created. So how this particular four objects are going to remove here. Now observe carefully this. The same method again we are going to call internally in the debug mode. So how it is working internally, it is important. Okay. Now you can see. So remove all method I'm calling. So this is the particular collection we are passing here. Okay. What is this particular collection will contain here? These are all the values. So 12, 45, 78, 96 here. And we are checking if this particular object cannot be null. If it is a null, we'll get an exception. Now internally, simple code they implemented. If this particular object is equals to null, we'll throw in this particular null pointer exception. Okay, we're trying to throw in a null pointer exception here. This is one of the important example we need to understand. So modified we are making false. We are calling iterator. Getting the point. Now, if we observe carefully, if this particular IT, getting the point. So if this particular IT is a reference of this particular iterator, now we are having IT dot has next. Okay, IT dot has next. So we are going to call this while loop multiple times repeated here. Finally, so C dot contains. Okay, so contains method. So far we did not discuss about the contains method here. Now we will not focus more on this particular contains method. We'll focus on the remove method. Okay, we'll focus on the remove method. So how this remove method it is going to work? If this particular element contains here, now it will call the remove method. Now you can see what happening internally. So whatever we are passing here, after fourth iteration or fifth iteration, this condition is satisfied. Once this particular condition is satisfied, now again I'm calling the remove method. I'm calling the remove method. Now, so this remove method internally, it is not taking any parameter. So what you understand, the first, whatever the remove method we have here, the first remove method it is called. Okay, without the parameter. So we discuss the remove method, how it is going to call. But only the difference is here, it will call the within this particular loop concepts here. Okay, it will call the within this particular loop concepts here, and it will try to remove the specified object here. Only this is the important. Any method, if you call the add all method, remove all method, and the single method only it will call internally, but the values are going to call multiple times. The methods are going to call multiple times here. Okay. So this is we need to understand very carefully. Getting the point. This is the way the remove all method is going to call internally. Okay. This is the way the remove all method it is going to call internally. Now finally, remove all, it's a similar to the remove only, but only just the parameter we are going to pass multiple object, and the multiple object internally, it will call one by one based on the specified loops here. Okay, based on this particular specified loop, the values are going to call here. And another one, retain method. Another important one, retain all method. So how we can pass this particular retain all method? Again, I'm going to call the same AL here. Okay, whatever the array list we are having, the same. Sorry, yeah, this is the array list, right? Whatever this particular array list we are having, I'm trying to pass this particular array list here. Now, what you need to understand here, how this particular retain all method is going to work internally. How this particular retain all method is going to work. Now you can see whenever I'm trying to call this, again we'll understand the in the debug mode only how this particular code is implemented. Basically, retain all method, what it will do, it will compare here. Any object is matched here, the matched records are available, and unmatched records are going to remove from the linked list here. Okay, this is the simple one. Whatever the match records we are going to have, so those match records are available, and unmatched records are going to remove from the particular specified collection, something like a linked list. Now finally retain all I'm calling. Now, so again we are checking this particular condition. Again we are checking this particular condition, but see here we are providing not condition. Whatever the remove all method we identified, whatever the remove all method we identify. So the remove method does not contain this particular not operator. So somewhere above or below we will have. Now you can see, so code is same. C dot contains it dot next we are having, and here we are not using this particular not operator here, and here we are using not operator. Here we are using not operator. Getting the point. So this is only the differences we are having. Getting the point. This is only the differences we are having. Retain all as well as this particular remove all. Getting the point. If any one of this particular value it is or the node is not matched here, what happens internally? The node is going to remove. Okay, contains basically will return true if this particular the whatever the value which is available inside this particular specified collections here. If it is not available, we'll get as a false. Whenever the value is not available, this particular condition will satisfy. Whenever the value is available, it will return true. This condition will make as a false because opposite way it's going to work. The not operator we already discussed in the previous example. Getting the point. This is important. We need to understand here. Okay, iterator it dot has next here, and so this particular value it's not matched here. So whenever it is not matched here, it will return true. So it is removing here. Okay, modify true. And the second also will not, the value is not available. This condition will satisfy here. And the second also, third also same condition will satisfy. And the fourth, I hope it will not satisfy. Sorry, I came out here. Now we'll go for the one more time. But now you can see whatever this particular array list, the value we provided here. So 12, 45, 78, 96 here. Now only this values are we are having. Only this values we are having. And remaining A, B, C, D, Y, Z, W, X, Y, F, all the values are removed. All the values are removed. Why these values are removed here? Because these records are not matched with this particular array list here. Whatever the matched records only, it will keep, and unmatched records are going to remove from the specified collection. So from the which collection it's going to remove? From this particular LL. From the linked list only, it will try to remove this particular value here. Okay, this is one of the important example we need to understand regarding this particular linked list. Regarding this particular linked list here. Okay, so any questions here? Anyone having any questions? So remove all method as well as retain all method. Okay, so if you don't have anything, now what all the collection related methods are pending? I hope contains method, contains all method. Okay, if we identify the contents, we can easily understand the contains all. Because contains all internally, it will call the same contains method. Okay, it will call the same contains method. Now we'll move on to the contains method, how it will work here. Observe carefully the retain also I'm trying to comment out here. And finally, contains method I'm trying to call this, and here I'm going to pass this particular object. So I will try with XYZ. So right now we don't have this particular XYZ, but we'll identify how this particular the linked list is implemented internally to call this particular contains method. Getting the point? This is important, we need to understand. So now observe contains method I'm calling it. Now finally index of method we are calling. Okay, internally, what is the method we are calling? Index of method. Where this particular index of is implemented. So if you go to this particular collection, so this is the index of and last index of. Okay, internally contains is depending on the index of method. So if we understand this particular contains, we can easily understand this particular index of also. Okay, so observe carefully because one of the methods are linked with another methods here. This is very important here. Now back to here. So where we are having inside this, again I'm trying to move index of method internally. Index of method basically it is returning the int value. The contains method will internally it will return the boolean value. Okay, getting the point. This is important here. Whatever the object is available, it will return true or false. So index of method, whenever we are passing this particular object, it will try to return the in the which specified index location the particular object is available. Okay, so this is all about the index of one. Now index, the default index we are making as a 0. The line number has like 600. Now 601, what I'm doing here, object. If this particular object is not a null here, because explicitly we provided XYZ. Because of this, it's moving on to the else section. Now you can see, so else section I received here. Now again, just now we discussed about this particular loops here. Okay, so from first to last, whatever the nodes we are having, all the nodes are going to repeated here. All the nodes are going to repeated here. Now what you can understand here, if getting the point, if this particular object is not satisfied, if this particular object is not satisfied, it is trying to return this particular index here. It is a simple one. Okay, it is a simple one. Internally, we are calling this particular equals method. Internally, we are calling this particular equals method. If the item is matched, it will return the when this particular item is matched. So the specified index will return. So you can see the 611 index location. Explicitly, we are increasing this particular index value. Okay, this is very important. We need to understand here. Now observe carefully index plus plus. Okay, and now you can see every time the index is increasing, but whenever the condition is satisfied, up to the whatever the value we have inside this particular index, the index will return. But based on our example, so it will keep on increasing. Getting the point? Keep on increasing. But here, any object is going to match, so no object is going to match it here. Getting the point? So finally, even though the index value is increased, finally we'll return the -1 only. Okay, so observe carefully. It is trying to return the -1 value. Okay, so here, whatever this example, this value is trying to return. Why it is returning? This condition is not satisfied. Getting the point? This condition is not satisfied. Why it is not satisfied here? Because the item, whatever the item we provided, the item no longer available inside this particular linked list here. Getting the point? This is important, we need to understand. Because of that, it is trying to return the -1. So whenever, if it is greater than or equal to 0, it will return true. Otherwise, it will return false. But in our case, we are getting as a -1. Because of this, it is returning false here. Okay, it will return false here. Now, finally, what I will do, the same contains method, instead of this particular XYZ, now I'll remove XY is there. So something like we don't have. YZ. Okay, I'm calling YZ, and again we'll see how it will execute this particular YZ, because this object is available inside this particular linked list here. Okay, observe carefully. Index is 0. This O is not equals to null, and we are moving into the L section. We are checking the item. If any item is matched with this, we'll returning the specified index. First record is not matched. Okay, second only it is matched here. Getting the point? Second only it is matched here. So once the second is matched here, it is trying to return the index. What is the index we are having? Something like 1. Whenever we are having this particular 1, it will return true. Why it will return true? What is the condition we are having there? So we are having the condition greater than or equal to 0. Whatever the value we are going to get here, so if it is greater than or equal to 0, it will return true. So here we are getting 1. 1 is a greater than value only. So compared to this particular 0, 1 is a greater than value. Okay, this is we need to understand very carefully. So finally, now I'm moving. Finally, it is trying to returning this particular true value. So this is the contains method, and internally we identify index of method. Because contains method internally, it is calling the index of method. Okay, so if I'm going to print this, because this particular contains method internally, it is trying to return the boolean value. Okay, it is trying to return the boolean value. So you can see true we are getting. We are getting true because whatever the YZ, the value we provided, it is available. It is available. Okay, so we identify the index of also. We'll move on to the last index. How this particular last index is available. Again, we don't need to discuss about the contains all. So how this particular contains all will contain internally. Now observe carefully. LL dot. So contains all. Here I'm going to pass this particular AL. So simply I'm explaining this without executing this particular code. Now observe. Contains all will contain the some list of objects here. Now each and every object is calling with the help of this particular loop here. So based on this particular loop, how many times this particular loop is going to repeat? So same time this particular contains is going to call. Okay, same. The contains internally, it will call the index of here, because this contains basically where we implemented inside the object collection. Because of this, it is not calling, but here now you can see O dot equals to IT dot next. Getting the point? So here the same code, whatever the code we identified here, it is trying to repeating same. But instead of the for loop, here we are using the iterator. Instead of the for loop, we are using the iterator. So same code. Getting the point? How we are checking the value is available or not? Equals method. Here also we are using the same equals method. Okay. This is all about the simple example on the contains and contains all method. Okay. Contains and contains all here. Now finally, what we can understand here, the last index of. Okay. Last index of method. How this particular last index of method will work. And now what I need to understand here, if I'm going to provide 96. Okay, if I'm going to provide, because last index is basically whatever the object we are passing, and it will try to identify the for this particular object what is the last index. Okay, if we have multiple index, so before going to discuss about this, now here after this particular set 96. So before calling this last index of, now I will print the value. So 96 first record and 96 here also we are getting. Okay, we have 296 here. First record as well as second, third, fourth, fifth, eighth. Okay, the eighth record also we are having same 96 here, and first record also we are having same 96 here. Okay. Now what I will do here, I am going to call this particular last index of the same value I'm passing 96 here. Now 96 will return some data. So why this semicolon? Okay. Now observe carefully. Last index of I'm calling inside this particular println because it is trying to return the some value. Now you can see what is the value it is returning? 7. Why it is returning 7? Getting the point? Because we are having first also, right? So it basically it needs to return the first. But right now we are getting the this particular 7. It is starting with a 0 to 7. Whatever we calculated, the same value only. But why I'm getting this? Because this will work on the last index here. Whatever the value we are having, getting the point? What is the last index of this particular value? Even though if the value we provide as a 10 times, but finally it will try to look up the last index only. Getting the point? It will try to look up the last index only. This is one of the important example we need to understand regarding this particular last index of here. Now what I will do here I will try to provide this particular last index of internally how this code is implemented. Now you can see what we are doing here. Here we are trying to check this particular loop here. So now you can see from last to first. Getting the point? Last to first we are getting here. Because it is a last index here. Because of that last index we are trying to load from the last. So whenever we are loading this particular last here, which value it is going to load? This double X here. Okay, later CD and later 96. Getting the point? Later 96. Now you can see we are decreasing the index minus minus. Last we are loading and last dot previous year. Because for the last record, we don't have a next record. We don't have a next record. Only we'll have a previous records here. So because of that, we are calling this particular loop in the previous order, and each previous dot item whatever we are having, we are checking with this particular object. What we passed here inside this particular object? 96, and 96 equals to this particular item. So when this particular condition will satisfy, so first iteration, second iteration, and third iteration. In the third iteration, this is going to match here, and it will return the whatever the index is matched here. Okay, whatever this particular index is matched. Now you can see index initially size. Index initially size, and it's keep on decreasing the value. How many times this particular loop is going to repeat it? Okay, this is all about the simple example on this particular lost index here. And index of how we implemented here, something above I hope. Okay, yeah, this is the index of, and now you can see index of next year. Index of next we are having. So basically it is trying to do this particular forward direction for this particular index of method. Okay, and for this particular last index of here, what is doing internally? What is doing internally? It is trying to do it is trying to like repeat the loop in the backward direction. So it's like a reverse here. So this is working on the reverse and it is working on the forward direction. This is important because here we can see next, because we are loading the first record. From the first we'll get an next records only. We'll not get the previous records. Okay, and for this particular last year we'll get only previous records, not the next records here. Okay, this is the last index of how it's implemented, and the same way the index of method how it is implemented internally. This is one of the important here. This is very important we are discussing because linked list is something some difficult compared to this particular array list, because internally it will connecting multiple nodes, next node, previous node, item. So how the next node and the previous node we are going to have the communication. But inside the array list, So this kind of linking information not available. Directly we'll move on to the specified the index here, and we'll try to work on the specified values here. Okay. So any questions here regarding this particular last index and last index of here? Okay. So if we don't have anything, now what I will do, before going to call about the clear method, now we'll understand the list iterator. So list iterator and one more list iterator we are having into index we are expecting it. We'll see how these two list iterators are going to work internally. Now here I'm going to comment out this last index of contains and get also. And finally ll dot list iterator I'm going to call. Getting the point. So I'm going to call this particular list iterator. First we'll identify how this particular list iterator is implemented here. Now internally it is calling this particular list iterator 0. So it is calling list itr here. Based on this it will try to return the list iterator here. Okay. So we'll see how it will work. List iterator dot, what is the method we can call? Has next. Getting the point. So first we need to call the has next only, because we already discussed this example in the array list. Getting the point. We cannot call the has previous. So we don't have a previous records. We'll have only next records here. And from this particular next records we can print list iterator dot next year. Getting the point. List iterator dot next year. Whenever I'm trying to print this, now all the values will print here. Okay, these are all the values we are getting. So instead of doing this, now what we can do, I'm giving the space here and we'll call the print method. Okay, this is the values we are getting here. And finally, so we can move on to the has previous also. Here we can print this particular has previous and previous. Now you can see, oh, so we cannot find out this how it is printing internally, because all our values are printing on the same line. Okay, so I'm printing one extra line here so that we can understand here. This is for the next year and this is for the previous, and whatever this particular line number 40 we are printing, this values are printing because of the particular line number 40. Now what you understand here, this particular section, it will keep on the backward directions as well as forward directions. So this is the major advantage we are going to get from this particular list iteration. Okay, this we discussed in the last example also. The same example I implemented with help of this particular two loops here. Okay, any questions on this? The list iterator, how it is doing internally. This is, we'll call it as a forward direction, and this will call it as a backward direction. Now you can see WXCD 96 and WXCD 96. Okay, so this is from the 0 to something, whatever we are having 10 or 12 elements, whatever we inserted into the linked list, it is continuing. And so 0 to 12, just I'm imagining, and 12 to 0. This is, we'll call it as a has previous and This will call it as a has next here. Has next because we'll have the next values and we'll call it as a previous values here. This is important information. Now finally, what we can check here? Finally, what we can identify here, we can move on to the clear method. So anything we are placing, okay, we have a sublist here. How this particular sublist is going to work? This is important here. Let me comment out this also. Sublist method. How this particular sublist method it will work internally. Sublist I'm providing. I will provide 0 and the 2 index I'm going to provide as a something like a 4. Okay, something like 4. Now what we can do, we'll try to call this method in the debug mode so that we can understand here how this particular sublist is going to call internally. Okay, sublist we are calling and I'm moving inside this particular sublist here. So we are calling range check here. Get in the pen. We are calling this particular range check here. So the range check will satisfy. Get in the pen because we are given the value within the range check only. Now you can see what we are doing here. So if this, whatever this particular, this keyword, if it is instance of, now you can see instance of keyword we are using here. Now I will identify how it is working internally. Random access enter. So again, we are not getting this here. Okay. So we cannot understand here whether this condition is returning true or false. Well, now what I will do, here I will put a breakpoint here. So this is only the another option we are having. Because the instance of is not matching it, like it is not returning the condition is satisfied or not. Because of this, we could not understand. So which class is going to execute internally? Because random access sublist is a one class and sublist is the another class. Getting the point? We have two classes here, so we don't know which one is going to satisfy because this. What is the this here? This is trying to return the linked list. Now, if I'm going to provide this class is implementing from this particular random access or not. To understand this, what we need to move on to the top here. Now you can see, oh, we are inside this abstract list. Okay, now we are inside this particular abstract list. Because of this, it is not matched this. Okay, anyway, now I'm trying to move on to the next line. So finally, it is calling sublist here. It is calling sublist. Now if you see, internally it is calling the constructor. Basically, this is the constructor. Okay, this is the constructor we are calling and we are trying to set this particular values. So root we are setting. What is the root we are having? Linked list. These are all the root elements we are having. And parent we are having null. Offset from index here. Size we are doing this some minus here. Getting the point. True index to from index. Whatever the subtraction value we are going to get, the value we are passing here and mod count. Okay, mod count we are having. Now you can see. So this is the list is it is returning here. It is returning list, but how we can understand here? So what kind of the list it is returning here? So if I'm going to print this, if I'm going to print this, we'll understand here how this particular the sublist is working. Now you can see 0 to 4. These are all the values we copied here from this particular whatever the linked list we are having. Okay, so imagine how it is calling. Sublist is a basically substring how we define inside this particular string. We'll provide the like range. We'll provide the range. The within the range, whatever the values we are going to have, the values are going to copied here. Okay, this is the purpose of this particular sublist method. So sublist we identify in the array list. Same way, now we are trying to identify inside this particular linked list here. Okay, So any questions regarding this particular sublist? Because it is a
No,
similar
sir.
method. Yeah.
Sorry. Sir, 0 to 4, is it 4 elements or from 0 index to 4th index?
So basically, now if you see 0, 1, 2, and 3. So it's not going to load the particular fourth record, because this is the range between the values only it will load, because here it will try to use the less than 4, not the less than or equal.
Equal. Okay. Thank you.
Okay. So finally, now what are the other method we are having? Clear method we are having. Before going to discuss about the clear method, now we'll move on to the queue interface. So what exactly the queue interface is working? So this remove method we already identified. Now we'll move on to this particular poll method. So like how this particular poll method is going to work internally. Okay. So now I'm calling this. How it will work internally, we need to understand this. Now you can see we are loading first record here. It's like a first node we are loading. And if this particular first is null, we are returning null. Okay, otherwise unlink. Getting the point? This method this unlink method we already discussed here. But what is we are doing here? We are doing the ternary operator. This is important here. Because this is the expression, whatever the expression we are having, if this particular expression returns true, this null it is going to return. Otherwise, it will call this particular unlink first here. Okay, it will call unlink first. This is one of the important example we need to understand, because internally we are already familiar with this particular method. Unlink how it is going to work, because we are passing f. F is a first node. The first node is going to unlink here. And another method what we are having, so this particular element here, what exactly the element method will do internally? Whenever we are calling this particular method, the poll method, what happening internally, it is trying to remove the first element from this particular linked list, or we can call it as a first node is going to remove from this particular linked list. If the first node is not, if the first node is null, we'll get as a null here. What about this particular remove here? Whatever we discuss here, remove method, what happens internally? It will keep on one by one, or how it is going to work. Okay, so we'll see one more time inside this particular linked list. We'll identify how this particular remove method. Remove first method only we are calling, and internally unlink first. Getting the point? So see carefully. This remove method internally it is trying to throw an exception. Okay, whatever this particular the poll method we discuss here right now, this method simply it will return null. Simply it will return null. Getting the point? So this is the differences we need to understand. If the first record is not available, which exception we are going to get? No such element exception. But whatever we discuss this particular, the poll method, it is not going to get throw any exception. It will simply return null here. And same way, ll dot element here. ll dot element I'm trying to call here. Now observe differences I'm explaining here, because whatever the methods are implemented internally, all the methods we identified here. All the methods are identified. We need to focus more onto the differences, how this code is implemented. So which method we are calling internally? Get first method. Now you can see the get first method, it is trying to throw an exception. If the first record is not available, we'll get an exception. Getting the point? So this is applicable for this get first as well as element also. this is applicable for this particular element as well as get first here. Because where this particular get first is available? Here. Okay, in the DQ interface, we have a get first. In the DQ interface, we are having get first. Now, so this is applicable this two here. Element as well as get first. Now, the last method, peak method, we need to understand how it is implementing internally. Okay, how it is implementing internally. Because, so this is the time to understand the code, how it is implemented inside this particular linked list here. All the section of code we identified here. All the section of code we already identified here, how it is working internally. This particular Q and DQ interface, most of the cases, it will try to load the value. By loading the value, if the objects are not available, we'll get some exception, and some methods not going to throw any exception. So this is only the most differences we are going to have. Okay, and here the some of the method we already identified. Those are coming from the collection interface, and some of them are coming from the list interface here. Now you can see the peak method, what is doing internally. Simply we are trying to returning the first value. Okay, simply it will try to return the item, the first item, whatever the value we are having. If the first item, like a first node, is not available, simply it will return null. Getting the point? This is the another important example we are having. So I'm requesting here now practice whatever this particular queue related method as well as DQ related method, whatever we are having here. Because it's a time to so debug the code, how we implemented this particular code internally, and how it is trying to returning the values here. Okay, so to debug the code, now what are the keywords we need to understand here? Getting the point? What are the keywords we need to understand? The first keyword I'm providing here. So if we are using this particular same Eclipse here we are having three arrows here. Okay, here we are having three arrows. So let me run this example in the debug mode so that we'll understand how these three arrows are available. Getting the point? Now you can see. So one array step into. So here you need to understand carefully. Step into. So what is the shortcut we are having? F5. Okay, this is the shortcut. Step into. Step into, basically what happens internally? It will try to move on to inside the method. For example, here we are having line number 23. We are having add all method. I want to move inside this particular method. Can you point? If I want to move inside this particular method, we can click on this particular F5, or you can click on this particular. Okay, so observe carefully. If I want to move inside this particular method, we can move on to the F5. And one more array we are having, something like this one. What we need to understand, basically, another one. Can you open? Another one, this is something like if I'm going to provide the cursor over to this particular array, now you can see it is what happened. It is trying to show as a step over F6. Can you open? Step over F6. So we'll identify how this particular F6 will work. So it will try to work on the line by line. Okay, it will try to work on the line by line. If you want to execute line by line, you can move on to the F6 here. Getting the point? This is important here. If we want to go on the line by line, we can move on to the F6 here. And another one we are having. Getting the point? Another one we are having this particular arrow. This will call it as a F7. Okay, F7. Now you can see. So right now it is not showing. Okay, basically the F7, what it will do, if you enter into the method, if you enter into the any block here, if you come out of the block, get in mind, if you come out of this particular block, you can click on the F7. Okay, F5, enter into the any block, method, constructor, anything. Okay, if you want to enter into the block here, you can click on the F5. So if you want to execute one by one, like line by line, you can move on to the F6 here. And if you want to come out of this particular blocks here, you can click on the F7. And we have a one more here. Now you can see this particular green one. Okay, here we are having green one. Getting the point. So how it is working internally? Now I'm trying to put an arrow here. What happening internally? Whenever whenever you are trying to click on this, so breakpoint to breakpoint. Where I'm putting the breakpoint here? Where I'm trying to put this particular breakpoint only one breakpoint line number 20. And if I'm trying to put one more breakpoint line number 30. Okay. So here to here between these particular lines are executed fastly. We cannot understand here. Okay, here it is stopped here, and whenever I'm trying to click F8, this shortcut will call it as a F8. Whatever there it is highlighting here, it is a F8 here. So directly from here to here it is going to stop. How it is stopped here? Getting the point? How it is stopped here? Same way, the line number 30. Whenever we are putting the breakpoint, it will stop here. It will stop here. Okay, this is important. We need to understand. Getting the point? This is important. We need to understand here. So if we don't have any breakpoint, only one breakpoint we are having, it will stop the application. If we have more breakpoint, it will execute. Otherwise, it will stop the applications here. Okay. So any questions? These are all the very important shortcuts we are discussing, because in the real time also, we'll use these particular shortcuts to debug the application. Any application, the 4 shortcuts are we are going to use. F5, okay, F6, and F7 and F8 here. These are all the 4 we are going to use. Okay, if anyone having any questions, so you can ask me. I will try to clarify this particular debug related information. If you are trying to debug the code, you will understand more how this particular the collection framework is implemented internally. Okay. If we don't have anything, now what I will do, I'm trying to move on to the another important section. So first we'll discuss about the another implementation class, vector. So vector, basically vector is a legacy class. We'll try to discuss later. Now we'll move on to the another interface here. So far, again I'm trying to providing diagram. Again I'm trying to providing collection, and this is we are having list, and this is we are having set here, and this is we are going to have queue. These are the 3 interfaces, and these 3 list interface is implemented by so AL and LL and vector. So we discuss about the array list and we discuss about the linked list. Now we have a one pending class called vector. So vector 1.2 or 1.1 is introduced here. We'll discuss later when this particular class is introduced here. Now we'll moving into this particular set, because set is again extended multiple interfaces. Okay, first we'll see what are the implementation class, because set is a interfaces. So we need to focus on the implementation class. So the first one is has set. Okay, this is the has set class we are having. We'll identify how this particular has set is going to implemented internally. Okay, this is we'll try to discuss about the hash set. Let's see. First we'll see the class, how this particular class hierarchy is implemented. How this particular class hierarchy is implemented. Let me stop this. Okay, now finally has set here. And this is all about the hash set here. Now, what is the class is extending? Abstract set. We already discussed the abstract set related the particular class. What all the methods are implemented and what are the methods are not yet implemented here. And implementing from this particular set interface. From 1.2 onwards, this particular class is available. And getting the point. This is important here. This is the name of the class we are having. Internally, it is extending from this particular abstract set here, and it is trying to implementing from this particular set interface. Okay. And what are all the constructor we are having? This is the default constructor. Now, if you see what happening internally, so map is equals to new hash map. Getting the point? What we are calling? We are calling new hash map. We are calling. This is very important here. So right now we are not discussing about this particular hash map information, but once whatever this particular section we identified, whatever just now I provided this particular section, list, set, and queue, this hierarchy completed, we'll move on to the another important concept called map. Map again will contain some different interfaces and implementation classes here. Map basically it will allow key value, key comma value. Okay, it is two values, and collection will contain only objects here. It will contain only object, but to map will contain key we can provide, and at the same time we are going to provide value also. This section it will something like it will expect the two values, and it is expecting only one value. Okay, this is the differences we need to understand. But first familiar with this particular collection, later we'll move on to the map. Now observe carefully what I'm doing here. Here, this is the default constructor we are having, and internally is trying to work on the hash map here. Okay, internally it is working on the hash map. So far, don't worry how this hash map is going to work. Now if you see where we define this particular references variable, line number 96 here. In the line number 96, I define this particular map here. Now observe, this is the hash map and is expecting two parameters, e comma object. Okay, so in our case, we are we are trying to provide as a element and object here. And this object, every time we are going to pass this present. Here we are trying to create a one object here. This is the final object we created. Okay, this object every time we are going to pass the second generic type here. Okay, whatever the second generic type we are using, we'll pass this particular references information. But this particular E, every time it is going to modify. This particular E, every time it is going to modify here. This is we need to understand very carefully here. This is we need to understand very carefully information. Okay, so finally we are identifying the default constructor. We are trying to create an object because here we are using new keyword. We are trying to creating the hash map here. And if I'm not using the default, if I'm trying to use again one more constructor, if it is expecting collection. Okay, if it is expecting this particular collection, now you can see one more hash map we are creating. Okay, but the constructor parameter we are providing like this. Okay, constructor parameter we are providing something like size, and we are trying to providing the ratio, and we are trying to providing something like a capacity. Okay, we are trying to providing this particular capacity here. We'll identify how this particular example is going to work here. Okay, this math.max. We'll discuss the math.max. Whatever the bigger value we are going to have, the bigger value will return. Okay, we'll see how this particular collection parameters constructor is working internally, and this is the one more constructor we are having, and here initial capacity, float, load factor. Okay, it's like a ratio we are going to call. So once up to the which point the hash map objects are completed or it's filled, it will try to create the new hash map. So this information we are going to provide something like a load factor. Okay, we'll discuss about this particular constructor also, how it is going to work, and only one constructor we are having, initial capacity. Initial capacity. These are all the constructor we are having. Only 4 constructors we are having, and this is the default constructor we are not going to use here. This particular default constructor we are not going to use because there is no public here. If there is no public, only we can access within the same package. What is the package? This particular asset is defined inside the java.util package. If you want to understand here, package name java.util. Okay, but whenever we are trying to access outside of the package, we cannot access the default constructor related information. Okay, we'll continue this session evening as well. So we are going to have an evening session. So 8 to 9 we'll continue the session here. Okay, so we'll identify how this particular, the continuation of this particular asset, how it is going to work. Any questions here? Anyone having any questions regarding our today's session? Say real-time example, basically we'll try to create a based on our application. For example, if it is a bank application, what we will do, we'll create a ATM related example. Okay, and the person related example, which person is going to buy this particular ATM, and we are going to create a current account related and saving account related information we are going to create, and transaction related section, because how many transaction he did and what is the amount of this particular transaction. We'll try to define this particular main model classes. So use this. So list of ATMs, or you can go for the list of persons, or you can go for the list of current account. Getting the point? And you can specify the list of savings here. So here, instead of providing the whatever we discuss this particular thing, you can come up with this particular example. So ATM, person, current, saving, and transaction. So we are going to have multiple model classes here. And if we observe the e-commerce, so inside the e-commerce, what we are going to have, like so user information, how many items he buys here, and how many items he booked here. Getting the point? How many items he made as a favorite here. So these are all the different model classes we are going to create. Getting the point? And if you are trying to work with any insurance applications, so insurance applications, what happens internally? So what are the plans is identified, and what are all the policies we is having, and what are all the transactions he made, and what are all the policies he claimed here. Getting the point? So what is the next term validity? So every information again we are going to create as a model classes. So everything we can use this particular array list to the particular model class here. Okay, so we'll see the simple example, but this real time is very different here, because for each and every application we'll create a multiple classes. So simply just I'm explaining, this is basically one of the online bank application. If I'm taking any another application, we are going to create a multiple classes here. Getting the point? We'll have a one or two example here, but just imagine the same way we are going to create the classes, but only the difference here, the name of the classes are going to different, but structure is same. Whatever the structure we are creating here, the structure same here. Okay, so we'll continue evening also. If we don't have anything, I'm going to stop the session here, and we'll continue. Today we'll whatever we are going to discuss, the hash rate information.